we are going to evaluate limits. So for these first few limits, 1, 2, and 3, we're going to explore these limit laws. If you look at number 1, this is read the limit as t approaches -1 of 5t squared minus 3t plus 2. I'll read it again. It is the limit as t approaches -1. So you have your t, the arrow means approaches, and then you have -1. The limit as t approaches -1 of 5t squared minus 3t plus 2. So in order to evaluate this limit, we're going to look at how the different limit laws apply to this function. Our first limit law right here is saying that you can break apart terms where you have addition and you can take the limit of each one separately. Similarly, our second limit law is the same thing for subtraction. We have both addition and subtraction. So in our first step, we're going to use limit laws 1 and 2. This will look like the limit as t approaches -1 of 5t squared minus the limit as t approaches -1 of 3t plus the limit as t approaches -1 of 2. Our next limit law says that if we have a constant, we can move that to the front of the limit. Well, we have that right here and right here. Technically, we have it right here as well if you consider this t to the 0. So then we will have 5 times the limit as t approaches -1 of t squared minus 3 times the limit as t approaches -1 of t plus 2 times the limit as t approaches -1 of t to the 0. Let's look at our next rule. The next one, number 4, is for multiplication. We don't have that. Then division, we don't have that. But look down at number 6. This one is saying if you have an exponent, you can move that to the outside and consider your whole limit. That is going to look like this. There we go. So let's see if we can fill this all through, simplify it down. So next we're going to need to substitute in -1 for our t value. So that will look like 5 times -1 quantity squared minus 3 times -1, replacing our t right here, replacing our t right here. We have plus 2, and then this one we have -1 to the 0, replacing our t right here. -1 squared is 1. 1 times 5 is 5. 3 times -1 is +3. Any non-zero number to the 0 power is 1. So this is going to look like 2 times 1. So that's 2. So 5 plus 3 plus 2, that gives us 10. So that means the limit as t approaches -1 of this function will equal 10. Let's try number 2. This one we have the subtraction in the top, and we also have our division. So now we can use this one right here. So what this is saying is we can look at the limit of the top. So the limit as v squared minus 5, and we have v approaching 1 over the limit, again, v is approaching 1 of just v. Check your division. We're not going to 0. We're okay. There's no restrictions there, so it looks like we're good. We can separate the numerator apart, and we can substitute in our 1. So that's going to look like 1 squared minus 5. Again, that would be 1 to the 0 if you wanted to do that. You don't have to consider that part like we did right here with t to the 0 if it gets too confusing. You can think of it as direct substitution of your value in as long as there's no restrictions. And then in the denominator, we have 1 because v is approaching 1. So 1 squared is 1, minus 5 is -4 over 1. So that means that our limit as v approaches 1 would be -4. And for number 3, we don't have any special cases. We don't have any division by 0. So from exploring our limit laws, we have seen that we can substitute straight in. So this is going to look like 2. And in the parenthesis for the exponent, we have 3.5 plus 0.8. So if we simplify that down, it looks like it's going to be approximately equal to 12.1